Right, this is the 8.1 instructional for Math 30-1, and it's when we start to talk about logarithms. And it's something that if you've taken chemistry, you've run into, and you've seen probably the log square on the formula sheet, and hopefully succeeded with it. But in math, we're obviously going to get into the logger in a lot more detail. Logarithms are extremely useful. If nothing else, they allow us to manipulate the exponent in a way that nothing else allows us to. But right away, some of the language is pretty important. When we do talk about a logarithm, we talk about how the value of the logarithm is equal to the log with the base in place of what we call the argument. And this is an important consideration because I'm going to try to use this terminology as I go. And I just want to kind of draw arrows. I'll draw a valid logarithm down here. We can say that 2 is equal to log base 8 of 64. Now, in the context of this argument, in the context of this logarithm, the value of the logarithm is 2, the base of the logarithm is 8, and the argument of that logarithm, or what you were actually taking the log of, is 64. Now, above, and I'll kind of circle it here, they talk about how to switch from logarithmic form to exponential form. I cannot overemphasize how important that is. A lot of questions that look difficult and unable to solve initially actually just require us to switch from log form to exponential form and likely do maybe a step or two beyond that. Now, I have seen a few different ways of how students will kind of memorize how to go from one into the other. And for one kind of annoying reason, it does kind of require you to put the logarithm on the left-hand side, although equal signs are bidirectional, so it doesn't matter. The technique that I have seen somebody do is you picture or you draw a little circle around the base, and then you basically draw a little loop. Now, I don't particularly like this technique, but what it's saying is that log base 8 of 64 is equal to 2 could be written as the base 8 to the power of the value and make it equal to the argument. Now, it's very important that that is true, right? 8 squared is 64, so 64 equals 64. Where this gets harder is what if there's an unknown? What if I tell you log base 8 of 64 is equal to, and I'll use x, I suppose. If we switch that into exponential form, I would see that this is really saying 8 to the power of x is equal to 64. Using our 7.3 technique, we could say that 64 is the same thing as x squared, therefore x has to be equal to 2. Now, the good news is that your calculator has a logarithm on it. The bad news is that it only has base 10. So what I'm going to show you right now, and depending on what calculator you have, that may not be true. I want to show you how to evaluate a logarithm like log base 8 of 64 if you don't have base 8 on your calculator. And the way that you tell that is that when you go to your math menu, if you see log base, then you can take a different base logarithm. Now, on your formula sheet, there is one log law. We're going to deal with the other ones in 8.3, I believe. If you have log base A of B, we can make that equal to log base C of the original argument divided by log base C of the original base. Now, the reason why that's so important is that everybody, well, if it's a scientific calculator, has log base 10. So one of the ways that we can deal with this is typically when we use this technique, it is most useful when we make C equal to 10. Now, I'm going to write this out for this question, but one of the things that the notes above addressed is that if I just tell you, okay, take the log of 1,000, we are going to assume that if a base isn't written, it's log base 10. And it actually just feels weird to write log base 10 because that is the standard or maybe default base, much like how the default exponent is 1 or the default coefficient is 1. Now, what that allows me to do is if I'm dealing with log base 8 of 64 in my calculator, I could do log base 10 of 64 divided by log base 10 of 8. And being able to write this as something maybe confirmable on your calculator is a big, big benefit. And I want to show you the one thing you have to be careful of is that when you do put in log base 10 of 64, you need to make sure that you close that bracket so the calculator knows that the log base 10 of 8 is not actually inside that logarithm. And we see that log base 10 of 64 divided by log base 10 of 8 is 2. That means that log base 8 of 64 is 2 as well. So that's a nice kind of concrete way of dealing with this logarithm. And as we go through the examples, we're going to talk about several different techniques for how to evaluate